Hi everyone, I'm going to discuss our recent work titled EuroMap DNN Task Mapping for Dynamic Thermal Management in High Bandwidth Memory. Emerging memory technologies such as HBM provide bandwidth as high as 386 gigabytes per second. 3D DRAMs consist of multiple DRAM dies vertically stacked together. Vertical integration causes high power density and poor heat dissipation and associated thermal challenges. 3D DRAMs exhibit thermal gradient across different dies. Assuming heat sink at the top, bottom channels are hotter. Consider a multi-core processor and an offchip 3D DRAM. Heating of memory channels from aggressive memory activity stalls the corresponding cores. Since the emergence of 3D integration technologies, thermal management in cores and memory is a first-order concern. We make a case to harness application awareness to reduce associated DTM overheads for deep neural networks. Deep neural networks consist of a series of layers, each representing a phase. DNNs exhibit varying memory access behavior across different layers. Different phases exhibit varying thermal impact on HBM channels. On a layer transition, the peak memory temperature undergoes significant variation. We propose an efficient task mapping-based GTM policy for DNN inference that attempts to minimize the execution time and keep all channels within safe thermal limit by reducing thermal stalls. Our policy EuroMap consists of a series of optimizations which we present next. EuroMap performs efficient core-to-channel mapping, categorizing cores into three groups: heavy, medium, and light. Mapping heavy cores to top channel, medium to middle, and light cores to bottom channel, leveraging the thermal gradient across DRAM dies. Next, we perform efficient task-to-core mapping. Considering a DNN layer as a task, we map the light task to light group, medium to medium group, and heavy to heavy group. Upon layer transition in an application, we migrate the application across groups. Upon layer transition in an application and no free cores available in the ideal core group, EuroMap swaps the application across groups. Further, upon layer transition and unavailability of potential swap candidate, EuroMap performs task-aware DVFS. On the memory side, we use low-power state-based DTM. Memory starts at initial state. Upon heating, goes to heated state, where heated channels are put to standby mode. Upon cooling, it goes back to active state, and again on heating goes back to heated state. To conclude, we propose an application-aware DTM policy for DNNs using efficient task mapping. We evaluate EuroMap using Comet Simulator and observe 7 to 39% reduction in inference time and 12 to 40% reduction in memory energy.